And so it's time to dust off our old friend, the buzzer. So let's just very quickly go through this as quickly as I possibly can, and actually pick out some of these things. So everything he says, let's just have a look at it all, shall we? So, thing that he says, number one, 200 years ago, Britain invented the railway. Let's have a think about this, because, firstly, no, we didn't. There's two elements to this, right? The first thing is 200 years ago. Well, no, the railways arrived in Britain. By several measures, it was not 200 years ago. The modern railway arrived about 200 years ago. The Liverpool and Manchester Railway was the first truly modern railway, right? Liverpool and Manchester. It was not the Stockton-Darlington. The Stockton-Darlington was, in my eyes, the last of the previous era. The first truly modern railway was the Liverpool and Manchester. So, okay, modern railways 200 years ago in Britain. Yeah, that's fine-ish. But it's not true, and it's jingoistic to suggest that the railways are a British thing, because we were merely kind of apprehending quite a lot of other... firstly, they arrived in Britain in 1594, so that's quite a lot more than 200 years ago. We had things that you and I would recognise as railways in the middle of the 1700s. So the 1760s, you'd have looked at things and gone, that's a railway. I absolutely recognise that as a railway. But even before that, even before they arrived in Britain, the Germans had been using them. The Germans had been developing the system that you see in front of you is a German system, and it's a guideway. It's a guideway with a wheel that reduce friction, and a guideway so that you don't steer it. It's self-steered. That for me is a form of permanent way. It's a railway. And the Greeks had this. They created limestone railways as early as like 600 BC. So we've had railways for a very long time. People often say, "Oh, it's a new transient technology." They don't know. The railways are as fundamental as the wheel in terms of how you move things around. That low friction interface between two strong things, which today is defined by steel on steel, is like that interface is as fundamental as the circularity of the wheel. It's just a fundamental part of moving things around with low energy. So sorry, very very much. Very much false on this one. Sorry, Grant. Let's go. Let's see what else our special boy has to say. Oh, but that means that some of the technology behind our railways are somewhat outdated. Does it? Why? So the railway created, even if you look back at just Liverpool and Manchester, so in what way is firstly, what are we using from then that we use now? Because back in the 1830s, we weren't using signalling that in any way reflects what anything has looked like for decades and decades. What possible technology are we using that has anything to do with 200 years ago? And I get his implication that, yeah, we've had railways for a long time, and that means they're outdated. But it's not true, because actually we've had, as we'll talk about momentarily, we've had technology updates in terms of signalling decades on and decades on. Every few decades we've had radical leaps, and indeed have been world leading in the thing that this government keeps attempting to be. We have been world leading in terms of our signalling technology in this country successively. And more recently. So this is very much a false one. What else is he saying? So now he's explaining absolute block signaling, which okay, fine, absolute block signaling is right. But the thing that's wrong here is the suggestion that this is the reason why we have knock-on delays right down the line. Because what he's describing here, you'd still have knock-on delays down the line if this was moving block signaling. So I'm sure everyone on here knows the difference. Absolute block signaling is where you have these essentially fixed, not necessarily by the signal posts, but fixed position blocks set geographically fixed. A train enters it and nothing else can enter the block while a train is in the block, and it goes out and then something else can enter. And you kind of end up with what he showed on the video, right? Which is where things enter the blocks and fine. A couple of things. Firstly, this is the system that's being introduced at the moment. They're not introducing moving block signaling. Moving block, is where the block follows the train around, and as the train gets faster, the block expands. As the train gets slower, the block gets smaller. And it means that you can theoretically squeeze a few more trains on the track. But fundamentally, whether you've got moving or absolute block signaling, you're still going to end up with... You still have headways. You still have things getting queued up when you haven't fixed the kind of the bottlenecks on the line. So, sorry, this is a false. And the next thing he's saying is we're transforming the East Coast Main Line. We're transforming the East Coast Main Line by investing over £1 billion in new digital signalling. No, he's not, because this was proposed years and years ago, and it actually dates back to it actually dates back to Labour years, but certainly ETCS has been in slow development since the late 2000s. It was deployed in 2011 on the Cambrian lines. And we've seen it rolling out on Thameslink in 2018, Crossrail, but this has been proposed for rolling out for a long time, well before SHAPS was in brief. So this is very much a false. Oh, dear me. Anyway, what's next? So, instead of old trackside traffic lights, the driver instead has a screen inside their cab, constantly updated with the latest information. Well, that is true. That is kind of how ETCS and ERTMS works. It is in-cab stuff, so that's true. There's no avoiding. That is a true thing. It means shorter delays, fast journeys, and more capacity on existing lines. Well, no, it doesn't actually, because in lots of cases on the East Coast Main Line, the East Coast Main Line is running as the capacity on the line is not going to be improved by changing from absolute to moving block signalling, because there are fundamental bottlenecks like Welwyn Viaduct, like Newark Flat Crossing. These fundamental bottleneck issues, everything in Peterborough still, bottleneck issues that just don't get resolved. The mixed traffic challenge that is the reason why you need HS2. None of that gets solved. So actually, no, you know what? It doesn't really mean more capacity, not to the extent that he is trying to suggest, and it doesn't really mean faster journeys either. No. So this is false. This is getting a false. What else is he saying? Oh yeah, he's saying all of which signals a very bright future for Britain's railways. No, it doesn't. This is just a necessary, essentially a like-for-like renewal, or certainly it's just a renewal of the signalling system with the next stage of upgrade. But it's not a radical change. I'm sorry. Anyone who's trying to suggest that is doing government's job for them, and it needs to have a little think about the reality, because it does not represent a fundamental change. Don't get me wrong. Traffic management is fantastic, very useful. In-cab signalling is fantastic, very useful. Removing line-side equipment is very useful. But the reason this is important, the reason we need ETCS, this project is fantastic, by the way. Don't let his stupid video take away from the fact this is fantastic, necessary work. It's really cutting edge stuff. Frustrating they've de-scoped so they don't include King's Cross, but anyway, the reason why this is necessary is because we could not renew all the signalling up the East Coast Main Line conventionally, and that's true for all the signalling that is coming. A lot of signalling, a lot of interlocking is coming up for needing renewal, and we just can't do it conventionally. We don't have the time, we don't have the skilled people, we don't have the resources, and so ETCS is an absolutely necessary and vital part of doing that, achieving that, pulling it together. So that's a buzz. The DFT. There are lots of good people in the DFT. Don't just refuse to make these things for him. Just refuse, please. The other thing that frustrates me is not so much that, okay, video fine, they're fairly innocuous, frankly. But what's frustrating is their press release that went with this, which this is an official Department for Transport press release, where they are referring to, well, okay, let's go through this, a variety of buzzes. So the first one is, let's talk about the Victorian infrastructure thing. Let's talk about the this Victorian infrastructure nonsense. £1 billion of government funding will be used to replace outdated Victorian infrastructure with cutting-edge digital signalling technology. This is true bollocks, and we're going to break it down. I know there's lots of questions. In fact, you know what? I'll get to the end of this segment and I'll go through the questions. That's the way to do it. So let's very, very quickly go through signalling history of the East Coast Main Line. So in 1930, there was a massive re-signalling of King's Cross. They did lots of things to re-signal King's Cross Station. They realigned the throat and did quite a lot of things. So 1938 Victorian. So it's already not Victorian. Let's jump to the next thing. Well, let's jump to 1951, which is, this is a picture of York Power Signal Box, actually. Here it is, York Power Signal Box. This was the biggest, let me just remind myself exactly of what the stat is, actually. I think this is the biggest and most complicated power signal box in the world at the time of its opening. That was 1951. And the whole East Coast Main Line continued to have upgrades, power signal boxes installed, right the way through to 1977, where King's Cross Power Signal Box was built, which was, again, absolutely cutting edge of what power signal boxes could achieve. So all this clever kind of interlocking, very, very clever kind of relay interlocking system, fantastic. 1989, we then jumped to the next, a genuine world-leading leap forwards. Funnily enough, around about the 70s was when British Rail Research had been developing solid-state interlocking. And in 1989, and they'd started rolling it out by this point. Through the 1980s, it had been rolling out in more and more places, and it really had a breakthrough when it was rolled out as an alternative to relay interlocking on the Highland Main Line. But when it arrived on the East Coast Main Line, the IECC in York, for example, the Integrated Electronic Control Centre in York, which here's a picture of it, in 1989, this was the absolute cutting edge of modern signalling. And it kind of still is right at that cutting edge, and unfortunately, privatization killed solid state interlocking, or didn't kill it, but it bludgeoned it to the point where it wasn't being sold anymore. There was already an export plan. This was being bought by European railways and others around the world up until the point where privatization killed it off. Railtrack came in and said, yeah, we're not going to do this. We're going to buy an off-the-shelf system from Europe because that's a good idea. When actually they'd had three major projects of what is basically solid-state interlocking, but it was the next the European market had picked it up and was running with it as a technology. CBI, computer-based interlocking, which is the same as solid-state interlocking, but it's just a different name for it. And that was those three projects that were announced by Railtrack. All of them were a disaster and have had to be re-signalled subsequently with SSI or with SSI-capable systems. So solid-state interlocking was seriously very good, and privatization killed off what could have been a very, very strong export market for us. Very, very frustrating. Never let anyone tell you that the state cannot be enterprising, cannot be innovative. It's bollocks. Anyway, there we go. Sorry, everyone who I'm saying bollocks about, but that's no one minds. I'm going to go through all the questions, don't worry. Anyway, so, and this continues because it doesn't stop there, because we're continuing to re-signal. In 2015, the York Rail Operating Centre opened, and in 2021, King's Cross was moved over to the Rock. So this is completely, this is a totally integrated new signalling systems, all this new clever solid-state interlocking, but now through the Rock. So we're continuing to have, and no one can tell me that what we're looking at on screen at the moment is Victorian. It isn't. So the idea that it's Victorian is bunkum. It's false. So what's the next thing that we're going to see that's false? The idea that this will mean faster, safer, and more regular trains for millions of people. I'm not sure it'll mean safer. The signalling rules are the same. So not sure about that. Faster, no, it's just not. No, I don't think it'll make much difference to timetables. I don't think it'll make much difference. Trains are running pretty fast at the East Coast Main Line at the moment. Regulation, which is the way that you fit different trains with different speeds and different stopping patterns in amongst each other, doesn't really get helped hugely by ETCS and European Rail Traffic Management. The reality is that mixed traffic situation is just a problem. It's just a major problem for route capacity. What else have we got? Oh yeah, that's right. The idea that union leaders brought the nation's railways to a standstill. No, government brought it to a standstill by not negotiating with the unions and actually not trying to rip them off and sack them. And another one, which is, I'm going to shout at Grant Shapps for saying, while union bosses waste time touring television studios and standing on picket lines, they're not wasting their time. They're literally fighting for their jobs, rights, conditions, and for the health of the railway. And he's saying, I'm busy getting on with the job at hand. Well, you're not, though, are you? Because you were making your machinations to run for leader. So, yeah, I'm calling this one a major series of false buzzes here. Lots of false buzzes.